the webinar with the subject Accelerating Manufacturing Innovations with Virtual Twin Experience. Now let's understand what the topic and the webinar is all about. The future of manufacturing is based on the concept of smart factory, which interconnects machinery and systems not only to production sites but also to the clients, partners, and other production sites. It is not just digitized manufacturing. Instead, it is digitized manufacturing informed by new ways of inventing, learning, producing, and trading that are shaking all sectors of the economy and society. Before we start with the webinar, we have an eminent speaker, Mr. Sudhir Gurtu, MD at LEADAC India. Mr. Gurtu has a rich manufacturing and automotive background. He was instrumental to set up and start General Motors India automotive plant in Gujarat in 1995. Prior to General Motors, Mr. Gurtu worked at Tata Motors plant. He currently heads the German company, LEADAC Private Limited, and he has been instrumental in setting up this company in India in 2009. LEADAC was formerly known as Voigt Industrial, and it started its operation in 2010. The company continues to grow at 20 to 25% over the past many years. I now invite Mr. Gurtu to deliver his address. Mr. Gurtu, the platform is yours. Please go ahead with your presentation and your address.
Thank you, Neha.
Thank you.
Big thanks to publishing industry and the sponsors for today, because you all chose a very good topic. It's very relevant. And actually, those who are not getting into such digitization or manufacturing innovation, I mean, these guys for sure will perish or for sure struggle. And if you look back, when I was just out of college and I was with Tata Motors then, it was a tough time. We had to go to a post office to make a call to back home, book a call STD, and then you get 3 minutes and you have to finish in that. You had a huge landline phone given to you. You couldn't possess one. You have to kind of use it just for those minutes. And from there, actually, then I went to General Motors from Tata Motors. There, but meanwhile, the technology had changed and we had GSM Nokia phones. They're also large and with keypads. But it was a pride to possess one at that time. And like from there on, you know how we have changed now to smartphones, touch phones. And you can talk from anywhere to anywhere, have a video call almost for free. Tomorrow, I guess this technology is going to change into motion-driven or just gesture-based calls or gesture-based mobile usage. So see the change in just my work time, and that's a small span compared to the huge. If you start from say industry 1.0 to say 4.0, 5.0 scale, it's a very small time. In that, we have seen such mega changes. And these are the companies like, unfortunately, Nokia is trying to catch up on, but those guys never believed in the touch phone then. In 80s, 90s, they were number one, Nokia. They were ruling the mobile market, kings. Today, you know what happened. And I believe the management never believed beyond QWERTY keypads, QWERTY keypads. They always thought this is there to stay, but they're wrong. Now, of course, they have gone into touch phones as well. But life has changed and you allowed entry of Samsungs and Apple phones and iPhones. So things are changing. Unless you catch up and stay ahead of the game, you'll struggle or perish. That's a very well-known fact. An example is this communications example I just thought I'll share as a story. Even you can have lots of examples. The paper Xerox industry. Xerox machine used to be a king, right? Way back. Today you have Kyoseras and the like, so many brother, so many new digital Xeroxes, and they've come in. And that old Xerox systems have changed. And that's how for almost every field you can give an argument where unless you keep pace with digitization, you are going to perish or at least struggle. So with that backdrop, it's very important for the listeners on this program webinar, being a great topic, as I said, to be alert and understand what changes are coming into society, what technology you can use, leverage. That's the least you have to do, if not innovate yourself. So in that respect, I think it's a very good session we have planned, EM and the rest have planned for you all, where you get to see what are these virtual twins and digital twins, and which can help you in innovation. Basically, you replicate the whole model, and instead of learning it the hard way, having produced it physically, you have a chance to actually check it out digitally and correct your model or your workplace or environment, whichever you're working in, and stay ahead of the pack. So even at LEADEC, we have used latest technologies in what we do, and we are a Stuttgart-based company. So we have a cell there who are kind of monitoring what's changing ahead, because we do a lot of manufacturing services in manufacturing industry, and in lots in automotive as well. And automotive, a big change, of course, is the EV, right? Electric vehicle coming in. The whole shift is going to the floor. Earlier it was under the hood. The key things were under the hood. Tomorrow it's the floor, which will have the real meat, which is a battery basically. So battery is almost 1/3 of the new EV cost. It's also 1/3 of the weight of the new vehicle. Huge change. So where we work in automotive, we are able to see all these auto plants, more so in Europe and US, those where we work, where they're changing and adopting this new practices, new digitization theories. Like I think this is one we heard at Audi plant in Neckarsulm, where they build R8. There they were trying out drones. So to use the vertical space, they're testing out drones to lift the steering wheel from the warehouse and bring it to the point of usage, or rather fitment by the operator. So you have, in fact, tomorrow, as you know, the steering wheel will be all individual. It will not be one black fits all. So tomorrow, the one lady may want a pink fabric steering wheel, while this business gentleman may still want a leather brown steering wheel. So this allows you the drone to pick up from the warehouse based on broadcast, which is the next sequence of production, and flying the new steering wheel from the airspace. So you free up the floor space as well, the trolley movements and the rest. So those kinds of digitization, technology change, you have to get to use and be the early ones to actually apply. If you're the last one, it will be no different than the communication example we saw. What happened to companies which were leading? They fell out. In fact, in one of the plants, I remember they're using holographics, I think Volvo, where they use holographics. Again, I guess you all know holographics, how you project something in the thin air. And so the door line, typically in a car plant, the door assembly line, where you just assemble the door, it's out of the body, taken out. And you put the scissor lift and door handle, the glass, everything, and wiring. So there's a broadcast for each door, that this one has to have a, let's say, a leather handle or a scissor lift, which is a different type, or pad, if door pad is different. So he's getting this holographic image in front of him, and he's able to make the door with that holographics, versus a printout which someone has to print, give it on the line, and that's where he reads what's the next door coming in the line. So these trials are all converting to reality now as we talk. People are using tuggerless movement, driverless, tuggerless vehicles. They're using conveyors which can shrink or expand. This is a Toyota. They're using that Toyota conveyors which could, based on the models. So if you have a model which has a lot of stuff in it, you need a longer conveyor. If you have a car model which has less stuff on it, you need a shorter conveyor, less stations. So again, this is a huge change. And yesterday's world, it was unimaginable. But all this change, the companies who are grabbing and adopting will be the ones who will make the moolah, as you go forward. So I guess, again, since I don't want to finish or give you the excitement which these guys will give to you, let's look forward to this digital twins and how it can help manufacturing innovation and change our factories of today to automated and digitized factories of tomorrow. because even in Make in India program, that's a must. India has to lead. So all the best to the session speakers coming up behind me. And thanks to the organizers for giving me this chance to be here. Thank you.
Those were great insights, industry insights given by you, Mr. Gurtu, and I really thank you for joining with us. So let's move ahead with our presentations. We have two speakers and who will be giving the presentations, and they are Sanjeev R, who is the business consultant, manufacturing and infrastructure at Dassault Systems, who will be speaking on Dalmia and the 3D Experience platform. And our second speaker is Murli Krishna Kumar, who is a senior application engineer, EDS Technologies, who will be speaking on some case studies of Dalmia. Let me give you a brief bio about the company. EDS Technologies Private Limited was incorporated in 1994 to focus on providing PLM solutions, implementation and its supports. The company is one of the largest technology solution providers in India and also a platinum partner to Dassault Systems. The company also has strategic partnerships with world leaders for additive manufacturing, for agronomics, for automotive and aerospace industries, for ensuring product data quality, along with other such services. EDST, that is EDS Technologies, has dedicated sales support, marketing, and customer satisfaction teams to address customers' digital twin business and their support requirements. We shall now move ahead with our first speaker, that is Mr. Sanjeev. Sanjeev has more than 12 years of experience in supply chain, digital manufacturing and operations, and product life cycle management space. Sanjeev is serving as a business consultant at Dassault Systems, leading a team of experts and consultants in supply chain and manufacturing domain, and helping organizations to strategize the smart manufacturing and industry 4.0 initiatives, focusing on segments of sales and operations, digital continuity, operations management, lean manufacturing, and logistics optimization across different industries. Just before starting the presentation, instruction to all the delegates. Before we begin with the presentation, I'd like to tell the audience that there will be a poll questions displayed between Sanjeev's presentation. So please put your questions, put your answers in the chat box. Let me hand over the screen to Sanjeev so that he can begin this presentation.
Yeah, thank you, Neha. First and foremost, good afternoon, everyone. So I think we just heard Sir telling about the need of digitization, the requirement of digitization, how the evolution of the digitization has been in the industry and the organizations, and then especially in the manufacturing sector now. Now, today, we know that, okay, manufacturing is one of the key things that is driving the economy, which is driving all the initiatives or the programs what the government is launching. So with that, let's see that, okay, how a virtual twin really helps, and then what is this virtual twin all about? So just to introduce Dassault Systems, so Dassault Systems is a French-based company. I mean, it's a purpose-driven company with value back to the earth, or value back to the human. I mean, with that as a vision. So we are about 20,000 plus passionate peoples across the world. I mean, a long-term driven company with 15,000 plus partners, and including EDS as one of our platinum partners, with 300,000 plus customers spread across different worlds. So with that said, I mean, now if I start about the virtual twin, Sanjeev, how is that people are leveraging different things? I mean, how is that we can go ahead and then have a virtual twin? First and foremost, to establish a virtual twin, we want certain applications. I mean, we want certain digital tools that needs to be present. Now, these digital tools, if it is on a single platform, I mean, now, for example, Sir was telling about the iOS or the Android that is coming in. So Android became a platform, and then people started making apps on that, and then it became so famous. I mean, it became so easy that okay, every aspect of the life can be encompassed within that particular platform. So similarly, if we take the engineering world, the manufacturing world, and if we have one platform, a single source of truth, where I can go ahead and then right from the conceptual design, the requirement gathering towards the realization of that particular product, virtually validating and then physically putting it out into the market and assessing the life cycle and then getting a lot of insights about the data that is being generated. So if I put all these things together where an organization's system of operations also is managed and then including the business operations. So that is what is 3D experience platform. So we have a platform where I can go ahead and then have the complete digital continuity and then build a virtual twin for 11 industries. I mean, we have put this across for 11 industries where there are specific applications, specific tools that are available pertaining to the domain, pertaining to the segment, where people can go ahead and then leverage the digital platform, I mean, the connected data to have the real insights or build a real virtual twin. So with the introduction of the 3D experience platform, let us understand a bit more on what are those overarching aspects, I mean, of a virtual twin. I mean, why is that people are seeing about a virtual twin? What are the elements of virtual twin which are coming in? So today, as I told, okay, right from the engineering, I mean, where I'll have to have a connected design, the connected manufacturing system, everything in a virtual way. I mean, where I go ahead and then do a design, do the detailed engineering, then I validate it for the assembly processes for the rest of the things. So I'm going ahead and then cutting across the value chain within an organization. I mean, it's an end-to-end digital integration of the engineering. Similarly, Sanjeev, whether virtual twin stops at that, not really. I mean, I'll have to go ahead and then connect that with my execution. I mean, with my manufacturing, with my plants, with my different supply chain ecosystems, where I'll have to go ahead and then see that, okay, how the executions will happen. What are the different problems that are originating from the shop floor? Are we addressing this? And then is that coming back into my engineering world? And then am I going ahead and then making progress in having a connected system? So will virtual twin really stop at that? Not really. I mean, today we are seeing the COVID, when we are anticipating recession, we have supply chain disruptions. So it is just not about me as a entity. It's all about the ecosystem where I'll have to go ahead and then see all the organizations. I mean, my vendors, my supply chain, my suppliers, my value chain, which are external to me, who are supporting me in growing. So if I have all these put together, I mean, that is when I'll have a real virtual twin. I mean, that is a virtual and then a real world integration. I mean, we call this as V plus R, the virtual plus the real. Now, understanding the virtual twin, what is that virtual twin encompasses? I mean, how is that people are putting up certain frameworks for this particular virtual twin, and then what are all the different things that people are doing? I mean, especially in the manufacturing or the production or the supply chain system, is that bringing automation and autonomous robots, the advanced robotics, and then having a plant automation and then digitizing the plant aspects is one of the first and foremost things. Next is about the engineering evaluation. I mean, probably today people were seeing on material removal. Now people are seeing about the material addition. I mean, instead of a classic machining process, can we have additive manufacturing put across? And then how do I take up my operations? I mean, can I have augmented realities so that I'll be able to go ahead and then project the right information to the shop floor? Can I simulate the value network? When I say told, okay, somebody is not able to give me a material, when the replenishments are not coming, when there are supply chain disruptions, can I simulate and then anticipate that, okay, how exactly or what will be the impact of those? Of course, I mean, across company, I mean, I may be having a group of companies, I may be an individual firm with different departments. How do I do an horizontal or vertical integration? And it's all about collection of this data, hosting this particular data. And there is a lot of data with this particular things that are coming up. The industrial IoT is one of the key things that, okay, I go ahead and then collect this information. And then people are now going ahead and then seeing that, okay, how do I manage my infrastructure? I mean, the cyber security and then the big data. Can I put it on cloud so that it can be seamless across the sites, or if it is one site, or if it is a connected site. So how do I go ahead and then completely build a twin? So this is exactly what people are looking about when they tell about the virtual twin, the digitization in every aspect of the work that what we do. So with that, what is that are coming out as solutions in the market? What is that Dassault Systems offers in this particular space for supply chain and manufacturing? So we call this as the global industrial operations. I mean, it is all about right from starting of a new product launch that I'll have to do. I mean, I may think of something where I'll have to build complete supply chain or the value chain. I mean, it all starts with the demand aggregation, the higher level aspects of thinking whether I should put a plant or should I go ahead and then have a warehouse. I mean, how do I go ahead and then do a strategic planning and then come out with some yearly plans? Then going ahead and then seeing some tactical level plans where I go ahead and then see that, okay, 3 months, 2 months, I mean, what are my projections? What are my sales projections? How my products are doing in the market? What may be the demand fluctuations? And then based on that, what should be the capacity I should operate in my particular plant? And then finally, on the detailed level, I mean, day in, day out, how within the four walls of the plants with minimal changeovers, with this automation in place, I can have the best productivity coming in. So this is the market lever. I mean, however, when I come to the organization, I mean, there are programs, I mean, the governance of the programs, the product engineering, which may be happening. I mean, the designs that we may be receiving or we may be doing. I mean, it is in both the segments. I mean, it is design is not only the product design, it may be the tool design, it may be the plant layout designs that I'm going to do. And then finally, taking that to the digital manufacturing world, where I go ahead and then simulate my particular plant or simulate the processes, come out with the manufacturing process plans, and then seeing that, okay, what will be the takt time, what will be the validations of this, whether the assembly sequences are right, whether ergonomically it is possible for me to achieve and then manufacture this, and then in which plant, what may be the throughput of these particular plants. So that is where the engineering and the industrialization segment comes into. Finally, I'll have to produce whatever I'm planning and then whatever is the market needs. So that is where the manufacturing operations management goes into, where it's all about the shop floor entities. I mean, right from the material inward towards the dispatch, where it goes across to the stores, it goes to the line side for the production. The supervisors has to get the right information. I mean, the digital continuity from whatever I had planned towards the execution needs to come in. The quality parameters, the CPK, CP values, where I'll have to go ahead and then record this from the machines, the integrations of the vision or the imaging systems today, which are helping in identifying and then telling that, okay, which is the right goods, which is the wrong goods. So all the quality parameters that needs to come. And then finally, everything as an asset. I mean, how do I go ahead and then do the plant maintenance? I mean, because this is one of the key things that people always see that, okay, Sanjeev, how do I go ahead and then reduce my capex when I have the right machines? I mean, if I maintain the right machines, definitely I can go ahead and then reduce those. And then finally, I have to dispatch, the mode of dispatch, and then the after sales support for my products as well. So if I encompass this, this becomes the entire industrial operations. And then the virtual twin, what I was speaking about, that, okay, how do I go ahead and then build this particular virtual twin? So I have a small video where I go ahead and then show that, okay, what exactly are this virtual twins? I mean, how it would look like. I mean, a day in a production shop floor with the digital systems that are coming in. So I start with a stand-up meeting. I mean, any particular system starts with a stand-up meeting where a lot of information exchange happens. I mean, maybe on the safety, maybe on the productivity parameters, maybe on the supervisors giving some inputs on how the plant went across, and then also about the number of operators who are there. So now I go ahead and then I do an assignment. Okay, person A can go ahead and then monitor a line. Person B can go ahead and then monitor the second line. If there are issues, I'll have to go ahead and then mark those issues, whether the day was good or there were certain problems in the environment, health, on the safety, and then certain instructions that can be given to the operators. And then finally coming out and then seeing that, okay, if there are any ideas or innovations which are happening. So this has triggered in a lot of data collections. I mean, a lot of data is being generated, a lot of actions have to be given. So now with these actions, whether the actions are complete, when I'll have to track that, who will do this particular actions, and then by when this will be completed. Similarly, now as and when I complete the meeting, then I'll have to go ahead and then start my production. So in the production, we were talking about the advanced robotics or the IoT integrations or the machine integrations that needs to be done. So probably I'm having few machining equipments where I'm seeing that, okay, what are the status of that particular things? And then if there is a tool failure, then I go ahead and then get the information about that particular machine. When is the tool failure? What is the downtime because of that particular thing? And then I should be able to get the horizontal integration that I was talking about, and from the engineering that, okay, which is this particular tool, what are the information about the tool, and then identify and then give what is the issue that has been coming out. I mean, maybe the tool is broken down. Now, if a tool is broken down, I mean, there may be multiple places where this tool is being broken down. I mean, I can have a heat map. We call this as 3D visual quality defect tracking, where I can go ahead and then identify where exactly the defects are. And then once I have the defects, I mean, I may be having a list of defects, which will trigger a maintenance notification. Again, it is a connected world. I mean, this is what is the digital continuity and the twin of how a plant can come across, where the maintenance operator can see that, okay, where exactly or which is the tool that has been broken down. And then he will either order for a new tool or he will replace that with an existing tool. Will my virtual twin end? Not really. Now, that was the real-time aspect. I mean, there was a problem, and then digitization was helping in identifying that particular problem. Now, let us go to the schedule. Okay, there is a downtime of, say, 1 hour or 2 hours. How do I go ahead and then see what are the plan changes? I mean, if there are certain orders, and then it was getting executed, and then if I want to see that, okay, because of the delay, what will happen to my plan, whether I'll be able to go ahead and then meet my plan for that particular day, or I'll have to see that, okay, what will be the impact on my delivery schedule. So I'll have to go ahead and then see the scheduling. Again, digital tools are helping me view the digital continuity story, but this is what is the twin, which is helping me that, okay, what is that exactly happening? And then how I'm going ahead and then managing that. So once I have the what ifs and then publish the plant will go ahead and then start working upon. Now, but the tool issue, I mean, there were 4 or 5 issues. So I'll have to do a root cause analysis and then see that, okay, what may be the probable issues or what may be the probable reasons for this particular issues. A lot of information comes from the engineers or the production supervisors or the manufacturing engineers who go ahead and then give the data, and then a lot of information may come across as issues or actions again, which needs to be taken up. And then I come back to my virtual world to validate. Okay, I've given a design. Maybe there is a process failure that is coming in. Now let us analyze this process failure. I mean, let us see that, okay, what was the particular machine? And then how is that I'm using again a virtual twin? I mean, now I'm in a virtual world where I'm going ahead and then taking the help of the digital solutions to analyze that. Maybe I'm analyzing the mission sequence and then seeing that, okay, what is that parameter which really has given this. So if I analyze this matrix, I may be able to go ahead and then see that, okay, there is something genuinely which is giving me this, probably the temperature. And then I go ahead and then see the corrective actions. Maybe I'll have to increase the coolant flow and then see that, okay, how exactly the differences are. Make those changes and then go ahead and then publish that back to the shop floor. Means I'm having almost a twin, which is going ahead and then telling me that, okay, what happened in the real time in the shop floor, and then what are the remedies in the virtual world, the virtual world helping me in going ahead and then modeling, simulating, and then visualizing that particular problem, and then analyzing and then helping me to go ahead with. The real time was all about the making, the learning, and then the experiencing of those. Now, what I was trying to do is that reduce the gap between that. I mean, today, majority of the places we see that, okay, engineering will just publish the data, or planning people will just give the data, and then the manufacturing world has to maintain with all the other things. But today, if we have this V plus R, or if we bridge the gap between the V plus R with this modelization, making, visualization, and experience, weaving a digital continuity. So that is when we have the complete virtual twin established. So there are a lot of examples where people are working, and we have almost 300,000 customers. I mean, this is just a few list of customers specific to each of these particular industries, where they are embarking on this virtual twin journey. So it is a journey. It is not that, okay, I'll be able to do this within a month or two, or maybe even within 6 months or 8 months. So it's a journey that I'll have to go ahead and then be ready for all the upcoming unknowns, what we have in the life, and then be competitive in the market. So with that said, I'm done with my presentations, and then I'm open for any questions. Neha, over to you.
Yes, so it was very insightful, and people must have got to know what the virtual twin is actually about and how is it used in the industry to actually make the products and streamline the product portfolios. So we'll take the questions at the end of the webinar. Once Murli Kumar's presentation is also done. So let's move ahead with the second presentation from Murli Krishna Kumar, who is a senior application engineer at EDS Technologies. Murli Krishna Kumar has rich industrial experience working for various automotive companies and has worked in various greenfield projects in manufacturing. He's currently working at EDS Technologies, helping manufacturing organizations realize the potential of digitization in manufacturing operations. Uh, Once again, instruction for all the delegates. Before we begin with the presentation, I'd like to tell our audience that there will be a poll question at the end of Murli's presentation, and also there will be a Q&A, and please put your questions in the chat box so that I can read out those questions, and Murli or Mr. Sanjeev can answer those questions. So let me hand over the screen to Mr. Murli, and he can begin with this presentation.
Hi Neha, thank you. Thank you. So before going into my presentation, Ms. Neha, is it possible to project the first two questions in our poll questioning so that we can proceed further?
Yes, absolutely. So I would request to put the poll questions. Murli, can you please continue with the presentation? We will take all the poll questions in the end of the presentation along with the Q&As.
Yeah, sure. Thank you.
You can begin with the presentation, Murli.
Yeah, sure. I hope you can see my screen now.
Yes.
Yeah. Good afternoon, everyone. Before going into the solution, I would like to talk about our organization, EDS Technologies. We are actually the platinum partners with Dassault Systems from more than actually 20 plus years. So we are a company who has finished, and we are in market from last 27 years, and we are all over India. We cater to 1,500 plus customers in all kind of aspects. We are mainly into the Dassault system portfolio. We are completely into the PLM. We even do the Industry 4.0 and digital manufacturing for all of the customers all over India. We cater to all kind of industries, as Mr. Sanjeev was showing previously in his slides. We cater to all the kind of industries like manufacturing, life sciences, and even mining industries. We are a robust. We also have a robust e-learning portal in this portfolio. So basically, we are a company who serve all the solution requirements in any kind of manufacturing scenario. So coming into our virtual twin experience. So recently, Dassault's portfolio has been implemented in Havels in India for uh, for the whole plant optimization and whole plant data acquisition. So Havels is a company which has 4 units all over India, which make cables, switch gears, electrical components, and also lighting fixtures. So they have 4 plants all over India. So they were having a fluctuating demand all over the plant, and they had a unique manufacturing methodology. So based on this, they wanted to have a proper handhold and they wanted to maintain a proper quality. So they wanted to eliminate all the shortages in their plant and try to have much more productivity in their existing plant. So they have opted for our solution. They are already users of, they already have their ERP and PLM, and they also have implemented SAP and Winchell. So their main business objectivity was to mainly grow into the environment excellence governance, and they are also planning to go for become a 4 to 5 it's a $1 billion company in next 4 to 5 years. So they want to catch with all the agility, and also they wanted to handhold their fluctuation in demand, and they wanted to have a top notch quality. They don't want to have any mistakes. They wanted to have a first time right product in their company. This was their main business values and goals. So for this we had an integration with Havels. So this is how the Havels plant was there, and where in which we have implemented the MES program with Havels. They had a 24 seconds of takt time. They were manufacturing around 3,000 units per day, and they're mainly comprised of this Siemens PLCs. So this is their whole process flow diagram, where in which they have implemented some control points to achieve the proper manufacturing without any kind of a quality drop. If you see here, they have this compressor ability where they wanted the torque completion feedback. So which is the key checkpoint. If there is any deviation in this, that would be addressed in the MES system, and we would take a counteraction immediately, and we will not allow that to be deviated. In the same way, in the whole process, there are multiple checkpoints which were integrated with the manufacturing execution system. There are 26 stations, and here, if you see, we had a torque completion feedback. Here we had a ING moving feedback, and here we had a vision camera where in which we would validate whether it is okay or not okay. Then only we would move the product to the next stage. In this way, multiple things were handled, and even the add-ons were integrated with our manufacturing execution system of Dassault systems. So this is the key architecture. We had integrated 86 machines and two main Mitsubishi master PLCs, and also they were using the key Kepware OPC server, and 45 plus parameters were recorded in order to maintain all this data. And this is how the and-on captures were working on. If you see, we have this breakdown maintenance notification ability, which was a full detailed version of implementation. And if there is any breakdown, immediately it would show a pop-up in their department. And even if there is a material shortage at a station, that would also pop up in the different department, and even the immediate information would go to the department and they would act upon the material shortage. Here we can even see the whole production dashboard, the whole visualization of plant, how the plan is going, how the current target is being achieved, and what is the total achievement. In this way, the whole company was connected and working in an integrated way, where our whole forum were managed and there is no deviation in quality while manufacturing. Here we would consider the method and material and even the quality work being monitored. Not only this, we had integration of CTP and CTQ data, wherein which we can have our whole SPC data integrated and get a correct objection handling, and also uh, proper utilization of the data, and to exactly act on what issue is there, where we can correct. These kind of data can be properly taken out from the solution. So thank you. This is how the implementation has happened in Havels. Miss Neha, that's all with me. You can even display the poll questions.
Okay, so can we have the poll questions, please? I feel the poll questions are being answered by the delegates. Shall we move for our Q&As? Okay. So yes, there's this first question popping up on my screen, and it reads, how does virtual twin experience optimize operations across the value chain? Anyone from the two speakers can answer this question.
Let me take the question, Neha. So I think as I had presented, so across the value chain, I mean, whether it is horizontal or the vertical integration. So virtual twin is all about building the digital version of the existing physical layout or the physical operations, or mapping the physical operations in a digital way. So one is about the agility and the speed, or the way that, okay, how I can approach a particular problem. So there, virtual twin helps in aiding a better decision making, a quick decision making, and then the quick turnaround time. So this is one of the key things why digital and virtual twins goes ahead and then help. The second aspect is all about the visibility, I mean, the transparency, and then the visibility about the data that is happening, and then or the way how the operations are running about. So this will get better insights about how do I go ahead and then make a decision on the expansions or the other things that I'll have to do.
Okay. The second question that is popping up is, it reads, how is this sustainable in manufacturing world? How virtual twin experience or virtual twin operations are sustainable in manufacturing?
Virtual twin itself is a backbone for the sustainability. And today, if I have to be more sustainable in the market, I mean, the digital valuations of the assets, whatever I have, and then the way that, okay, how I can go ahead and then use those particular data. And that is what virtual twin is all about. And that is where sustainability automatically is an outcome when I have the right virtual twin.
Yes, exactly. The third question that is popping up is what are the challenges as there are several new concepts coming up in the virtual twin experiences or operations. So, what are the challenges the industries are facing every now and then?
Uh, of course, I mean, as I told, okay, virtual twin is a journey. I mean, there are a lot of new things that are really coming up. I mean, people are today talking about augmented reality inside the ships, and then how do I manage the aircraft carrier operation? So the complexities are increasing, and hence the different technologies are evolving. So we have to do an assessment. I mean, typically we do an assessment. We see that, okay, where exactly are the pain areas, which will translate into the quick returns and also the right value propositions. So based on that, we start a journey of going ahead and then building this virtual twin. So that is how we address this concerns on multiple technologies or multiple tools that are available to enable the digital twin.
Exactly. The fourth question that is popping up is the market is set to grow at an astounding rate and it is projected to have a compound annual growth rate at 36% over the next 5 years. But the current adoption rate of the virtual twin is just 10% globally. That means there is a huge gap and an untapped potential to apply virtual twin reality into the technology or in the business area. So, what do you think about it?
So I think initially Sir had answered when he told that, okay, the evolution when he joined Tata Motors, the example of the post office where the phone and the STD calls were supposed to be made. Of course, it all starts with those kind of small things that will help grow. So today, yes, I mean around 10 to 20% is what is the virtual twin adoptions that are happening. But things are changing. I mean, we are seeing that, okay, the Indian market is one of the quick ones to adopt the technology. I mean, that is where we have seen the most of the way, the how, and the why of the adoptions that are happening. I mean, an example was Havels. I mean, Havels is into the fast moving electrical goods. They have almost like 17 product segments. Now they'll not be able to manage or see that, okay, how the growth will happen. I mean, or if they have to be one of the contributors for this 36% growth, without these adoptions, they may not be able to sustain. I mean, that is exactly why they're going ahead and then putting out these systems. And we are confident that, okay, this numbers are going to definitely raise. Then the awareness is what we are helping with these kind of webinar sessions that are being conducted.
Yes, right. So I feel there are more questions coming up, but I feel that should be taken offline. And now we can move ahead for our vote of thanks, and we can then conclude with our presentation. So yes, so I mean, like, I would like to extend a like warm vote of thanks to our wonderful audience for being part of our today's summit, and I would also like, heartily thank you for our esteemed keynote speaker who was Mr. Sudhir Guttu from DDAC India, and our notable presentators Mr. Sanjeev R from Dassault Systems and Murthy Krishna Kumar from EDS Technology. And it was an honor to have you both on board. And thank you for collaborating with us on this webinar. We'll see you next time. Thank you.